If we arrange some numbers into columns, we can see that easily all the even numbers are in the same column. If we rearrange those numbers in 3 columns, we can also see that all numbers with the multiples of 3 all line up together. If we arrange the same numbers in 6 columns, then we can see that both 2's and 3's multiples are aligned. That's because both 2 and 3 are the factors of 6. If we remove the number 1, because it's a special number and not a prime number, and if we use only the numbers those smaller than 20, then we can rearrange the numbers like this. And if we remove all the multiples of 2 and 3, but leave 2 and 3, then the numbers left are all the prime numbers below 20. The other way to memorize these numbers is notice that all odd numbers under 20, not counting 1, except 9 and 15, because they are the multiple of 3, and including 2, the only even prime number, that make up 8 prime numbers under 20. This list of prime numbers is more than enough for most high school math problems. But if we need to know more prime numbers, let's say all 1 and 2 digits prime numbers, well, if we continue from the table, since we already know that all columns are the multiple of 2 and 3, except columns 5 and 7, so we can extend the table with only these 2 columns, not all the numbers from 1 to 99. The simplified table will make our lives a little bit easier. Before we continue, we should copy the prime numbers 2 and 3 into the new table, so we won't forget. Now we can fill in the rest of the numbers. Since the original table was created with 6 columns, so the number plus 6 equal to the number right below. The right-hand side column is even easier. We can do the same, or we can just add 2 from the left, because that is how the original table arranged. Let's do the next row. 17 plus 6 equals 23, plus 2 equals 25. And continue to do this until the number reaches 97. This is all possible prime numbers, but we are not finished yet. Because the original table only eliminated the multiple of 2 and 3. When we extend the table, the multiples of greater prime numbers showed up. To eliminate the multiple of other prime numbers, let's start from 5 times 5 equals 25. Then 5 times 7 equals 35. 5 times 11 equals 55. 5 times 13 equals 65. 5 times 17 equals 85. 5 times 19 equals 95. And the next multiple of 5 will be the 3-digit number. The first multiple of 7 is 7 times 7 equals 49. Then the next is 7 times 11 equals 77. Then 7 times 13 equals 91. 7 times 17 equals 119, which is beyond our range. The next to check would be 11 times 11 equals 121, also beyond our range. We found 6 5's multiples and 3 7's multiples from this list. After we closed out those numbers, all the numbers left in the table are the prime numbers of 1 and 2 digits number. If we want, we can write it sideways like this. Let's go through this again. Write down 2, 3, 5, and 7 in 2 rows like this. Then add 6 to each number to have the next number. Finish the rest of the numbers. Close out or erase the 5's and the 7's multiples. That's it.